Okay, we're going to wrap up with dividing radical expressions. So this is definitely the hardest and will require the most practice. So you'll get some practice today, but I promise you when I see you next time, we'll practice this a little bit. There are always different circumstances when you might be able to simplify first to make it easier. So in person, we'll go over all of those little situations. But basically, these are your steps right here. And again, we're on page 9 in our packet. So first thing you want to do, if you see a fraction inside a radical, first thing you want to do is try to simplify the fraction if possible, because that will give you easier numbers to work with. And sometimes you might realize it turns out you have way less work to do. Second idea, or second thing you want to look for, is you're actually able, if you have a fraction under a square root, because of the quotient property, you can rewrite it as, a square root over a square root, as long as a and b are positive. So that's a habit we might want to get into, is just rewriting it. The next thing too, if we can simplify each one of those, a or b, we can try to do that. And then the last thing, and this is where it gets tricky, if the radical still exists in the denominator, that's a no-no. You may not ever, 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 under any circumstances, have a radical in the denominator and consider it simplified or correct. So anytime you're working with any of these problems, if there's a radical in the denominator, you have to do something about it to finish simplifying it. And when that happens, this is where you multiply both the numerator and the denominator by that radical in the bottom. And I'll show you a problem like that shortly. And then always look for simplifying. So sometimes we simplify up here and we're good and we don't have to do it down here. Sometimes we forget up here and we have to do it down here. Or sometimes we simplify up here, but maybe not enough, or some multiplication happened and we still have to simplify at the end. So always look for simplifying at the end on all of these radical problems. All right, so I'm going to do a couple examples with you. So looking at this one right here, so I see I have rad 128 over 8. So the first thing I want to do is go, can I simplify that? And turns out 128 is divisible by 8, and it actually turns out to be just 16. So really, this is just a sneaky way of writing the square root of 16. And we know that answer, it's 4. So this is an example of one of the easy ones, but it's actually kind of sneaky. So you got to look out for those. You want to make life easier on yourself. Because the other option, which we'll go over in just a minute, it'll come up on this one right here. The other option is a much longer process. All right, so now we're going to look at B. So we see we have 4 rad 7 over rad 8. Now we have a couple ways we can do this. So I'll do it both ways. Okay, so the first way is we need to what's called rationalize the denominator. Meaning we're not allowed to have a rad 8 in the bottom, ever. So what we can do is actually make the rad 8 disappear by multiplying both the top and the bottom of the fraction by a rad 8. Now if this rad 8 over rad 8 is just 1, right? Any number over itself is 1. So if I'm multiplying a fraction by 1, that's totally allowed. I didn't change anything. So that's one reason we're allowed to do that. Number 2, why we want to do it is because, well, rad 8 times rad 8 is rad 64. And what's the square root of 64? It's just 8. So what happens is that made the bottom turn into just plain old 8. And by doing that, though, now it's going to change the numerator. So what happens is we use our multiplication rules from the last video, and we go coefficient 4 times just 1 is 4. And now under the radical, 7 times 8 is 56. Now, a couple of things that we can't do and a couple of things we can do. Rad 56 and 8 are not in the same plane here. We can't take rad 56 and divide it by 8 and simplify it that way, because that has a radical and that does not. But what we can do is take rad 56 and break it down in order to simplify it. In fact, you have to. You're not able to leave it as just this. It's just not simplified enough. But before we even go and do that, I'm actually noticing, oh, I have 4/8. 4/8 is just 1/2. So right away, I'm starting to simplify it. So this one right now is at 1 rad 56, and you don't need the 1, but 1 rad 56 over 2. So I just, simplified it a bit. Now I'm going to take 56 and see, okay, can I break 56 down? I'm going to do this up here to save room. So 56, we know that's 8 times 7, and then 8 breaks down into 3 2's, 2, 2, and 2. So we have a set of twins, so 2 pops out, so we have a 2, and then what's left under the radical is we have a 2 and a 7, so that's 14. And now don't forget it's over rad 2, over plane 2. And now, of course, 2 over 2 is just 1, so the answer to this is just rad 14. So that's one approach. Another approach, and you'll get the same answer, is if you wanted to, you could have simplified this rad 8 to start, and you could have simplified it into a 2 rad 2, and then after that, you could have just multiplied top and bottom by a rad 2. I'm not going to do that problem with you right now because later one similar comes up, so we can discuss that then how you would work that out. Okay, so next one, and we're skipping D. We will not be doing any of them that have this plus sign or any sort of two terms in the denominator. So on C, we look at it and we say, all right, well, I have a radical in the denominator. Can't happen. I need to get rid of that. I'm looking at this and we can't actually simplify it. Now some of you might notice, well wait, I have a rad 5 over a rad 5. Can I cross it out and call it a 1? You're not actually able to do that because if you are simplifying something and it's like set up in this way, all three of these have to have terms that are divisible by that rad 5. So like what I'm saying is this 2 would have to have a rad 5 in it to simplify all the rad 5s and make them go away. So right now nothing can happen. The only thing that can happen is just like up here, we can multiply top and bottom by a rad 5 to clean up the denominator. So that's what we're going to do. So we're going to multiply rad 5 and rad 5. And on the bottom, again, the reason why we do this is because rad 5 times rad 5 is rad 25. The square root of 25 is just 5. So that actually does that. That'll always happen. Whatever's under there will just appear there without the little house. Okay, so now we're going to multiply this. Now this is a distributing thing, right? Because we have this, think of it in parentheses. We have to do rad 5 times 2 is 2 rad 5, and then plus rad 5 times rad 5. Now rad 5 times rad 5 is rad 25, which is just 5. So now we look at it, we have 2 rad 5 plus 5 over 5. So we're going to see, can we simplify it? No, we can't. It looks like we might be able to because we have a bunch of 5s there, but we actually cannot because these 5s cannot simplify unless there's something in here that can be divided by 5. And there's not. 2 cannot be divided by 5. And remember, these rad 5s and 5s, they're like totally separate. You can't actually like work with them together. So they are, I mean, they're not like terms, but they're just, they can't be messed with. So this would be our final answer, and that would be fully simplified. So I'd like you to pause the video and go ahead and try A and B. You can skip C. We're not going to be working through any problems like that. All right, so taking a look at these problems, hopefully you got those correct. So looking at A, square root of 25, again, look out for those perfect squares. It'll make life way easier. So square root of 25 is 5. And then 3 rad 12. Oops, I just caught a mistake on my paper. I wonder if any of you see it. My mistake is I forgot to simplify rad 12. So I'm going to go do that right now. So rad 12, right? So 12 breaks down into 4 and 3. 4 is a 2 and a 2. So we're going to have a 2 pop out multiplied by that 3 in the front. So that's really 6. And then underneath the radical is 3, and a 5's on the bottom. So that is actually the answer. I hope some of you caught my mistake. Okay, on B, now this one's a little bit trickier. So this is another option of something that you can do. So I want to go over this with you. Now some of you might have multiplied top and bottom by rad 80. And there's nothing wrong with that. You can totally do that. To me, multiplying, and remember, we don't have calculators in this chapter, so taking 80 and multiplying by 15 just sounds like a lot of work. So I decided, let me break down rad 80 first because I think it'll give me smaller numbers. So I took 80 and I broke it down into 8 and 10, and then 8 is 3 2s and 10 is a 2 and a 5. So what happened is I had a set of twins and a set of twins. So that became a 2 and a 2, comes out to 4. 4 times 4 here is 16. That's where the 16 came from. And then the leftover is the 5, so that goes there. So all I did right here in this step is I took 4 rad 80 and transformed it into 16 rad 5, which these are equivalent. It's like that's 2/4 and that's 1/2. Okay, it's the same thing. So I thought, multiplying top and bottom by a rad 5 sounds a little bit easier than 15 times 80. So now what I'm going to do is do what I did in all the other problems. I noticed that I have a radical in the denominator, so I have to multiply the top and bottom by a radical. Now this 16, don't mess with it. It does not need to be multiplied. It's not under the radical. It's totally fine. You do not need to multiply the top and bottom by a 16. You can. It's not going to be wrong, but it's going to be a lot bigger of numbers and just more work. So multiply top and bottom by the rad 5. So now we have rad 5 times rad 5 on the bottom is rad 25, which is 5. So now I took this 5 times 16, and that's where the 80 came from. This is my next step. And then 15 times 5 is 75. So I have rad 75 over 80 right now. Now I'm like, all right, well 75 needs to break up because 75 is 25 times 3. So if you look at 75 and you have 25 times 3 and then you have 2 5s, that's where this 5 came from. So 5 pops out, 3 stays underneath, 80 is still in the bottom. And the last step, 5 over 80 is 1 over 16. You don't need the 1. If you have it, it's no big deal, but you don't need it. And now, final answer is rad 3 over 16. All right, so you're going to do some practice on this today. So your practice is going to be in your packet. And the next thing you're going to be working on is page 10 through 11. You're skipping number 17 and 18. So that's part of your practice for today. Definitely work with each other, work with a neighbor, and the substitute does have the answer key for when you are finished.